Hi, and welcome back. We're now going to advance a little bit from our discussion of finding and creating points on the Cartesian plane to performing operations on points. And we're going to start by finding the distance between 2 points. Let's first break this down into components and then we'll combine them to find the distance. You've probably all heard the saying that the shortest distance between any 2 points is a straight line, and that's what we're going to find here. Let's say we have 2 points. Point 1 is -3, -1, that is -3 on the x-axis and -1 on the y-axis. And point 2 is 1, 4, that's +1 on the x-axis and +4 on the y-axis. Breaking this down into components, we have 2 rules here. And one says that to find the distance between the x values of 2 points, you take the absolute value of the difference between those 2 points. And same thing for the y. To find the y distance between any 2 points, you take the absolute value of the difference between those 2 points. So let's take a look at the example we mentioned here. To find the distance between the x values of points 1 and 2, we'll take point 1, which is at -3, and from that, we'll subtract the x value for point 2, which is at +1. If we subtract 1 from -3, we get -4. So that tells us the distance between the 2 points is 4 units. And the same thing for y. If we start at -1 for the y value of point 1 and subtract the y value of point 2 from that, we get -1 minus 4, which turns out to be -5. So the distance on the y-axis between the 2 points is 5. A question often arises as to which order we should subtract the y values and the x values of 2 given points. Above we subtracted the values for point 2 from point 1, but let's do it the other way around. Let's subtract the values of point 1 from point 2 and see what we get. We'll start with the x values again. Since the x value for point 2 is +1, we'll put that down and then we'll subtract the x value for point 1 from that. So we have minus a -3, which gives us a +4, the absolute value of which is 4. So we get the same number. Now let's try the y values. We're going to subtract the y value for point 1 from the y value for point 2. Again, we have 4, and then we subtract a -1, which gives us a 5. And the absolute value of +5 is 5. So whether we subtract point 1 from point 2 or point 2 from point 1 really makes no difference. But the goal here is to find the shortest distance between those 2 points. So how do we do that? Well, it actually starts by finding the distances between the x values and the y values like we just did. Now, this is something we'll cover more later, but if you've seen this before, you probably recognize it as the Pythagorean theorem, which says that if you know the lengths of 2 sides of a right triangle, then you can use a formula to find the length of the remaining side. We'll call the length of the differences between the x values here a, and the length of the differences between the y values b. And so finding the shortest distance, which is c, follows the formula you see here. C squared is equal to a squared plus b squared. If we want the distance c, we take the square root of both sides. Let's fill in the values here and see what we get. If we fill in our value of a, which is 4, and square that, we get 16. If we fill in our value for b, which is 5, and square that, we get 25. 25 plus 16 is equal to 41. Now, we could try to simplify this, but if we're actually trying to get a value, we would evaluate the square root of 41, which, unlike some of the problems we've seen up to this point, is not a whole number, but a decimal, in this case 6.04. I want to share with you a real-life example from personal experience. When I was in college, I had to move a reasonably long distance to get from college back home. Being a college student, I wanted to save money. The largest item I had was a table I used to study on, which was 11 feet 6 inches long, or 138 inches long. Now, I was looking at a rental truck online, and they had a 10-foot truck, and the next size up, which I don't remember what it was exactly, but it was more expensive. I looked at the inner dimensions of the trailer, and saw that it had a length of 9 feet 11 inches, or 119 inches long, but it was 6 foot 4 inches wide, or 76 inches wide. Now obviously I couldn't have fit my table in, going from front to back, let alone from side to side, but it dawned on me, I wonder if I could fit it diagonally. If I could do that, I could fit my stuff in pretty nicely. So I actually applied the formula that we just saw and found that the diagonal distance from corner to corner was 141 inches, and that was measuring the inner dimensions of the trailer. Since I knew my 138-inch table would fit within 141 inches, I went for the smaller truck and was able to save some money. So there you go. Next time someone brings up the practical value of some of the stuff you're learning, you can give them this story, or one of your own. Alright, let's take a break. When we come back, we're going to continue moving on from points to lines and see how they can help us solve problems and analyze data.